Well, hello everybody, and welcome back to Beau Maths. Hope you're having a nice day today. And today we're going to be practicing what we learned last time, which was kind of just some new terms on some familiar ideas with divisibility, multiples, and factors. So we're going to get comfortable using these terms, and we're going to get comfortable with some methods for them. And yeah, so let's get into it. So pause the video, try these out on your own first, and then we will begin. Alrighty. Question 1 says list all the factors of the following numbers. So first of all, we need to recall what a factor is. So a factor of a number is basically like a whole number that'll go into it or that'll multiply into it. So for example, if we look at the first one here, a factor of 10 would be 2, for example, since 2 times 5, right? So 2 times another whole number gives us 10. So we know that 2 is a factor of 10. All right, and then also similar from this, we can get that 5 is a factor of 10. But we want to list all the factors of the numbers. So how do we go about doing that? Well, there's kind of a process where we can just kind of go through a list of numbers, checking them as we go. But we don't want to have to necessarily check all the numbers 1 through 10, right? Or especially when we look here at 16, I don't want to have to check every number 1 through 16 to see if I can multiply it in to get 10 or not. So we might want to get a more efficient means of doing this. And one method is we only need to go up to half of the number. So if we look at 10, right? If we just check the numbers 1, 2, 3, 4, 5, I'm claiming this will give us all the factors. So if we had anything bigger than 5, it's never going to actually go into 10. Because 5 goes into 10 when we multiply it by 2, right? 5 times 2 equals 10. So that means we would need to multiply 6 by something smaller than 2 to get to 10. But it's definitely got to be bigger than 1 because, well, 6 times 1 isn't 10, right? So the number we multiply 6 by to get to 10 is definitely going to be a decimal. And then same thing with 7, right? Because 7 is bigger than 5, and we know that 5 times 2 gives us 10. Then we know that we're going to have to multiply 7 by some decimal that's smaller than 2 to get to 10. But that's, again, not going to be a whole number, which means that 7 isn't a factor of 10. Same thing with 6. 6 isn't a factor of 10. So basically, with all of these, it suffices just to go up to half of the number in terms of what we check for factors. So instead of checking 10 numbers, we only have to check 5 numbers here. So let's go ahead and do that. So for 1, is 1 a factor of 10? Well, yes, since we can do 1 times 10, and that gives us 10. So I'll list down 1 as a factor of 10. All right, 2, is 2 a factor of 10? Well, can I multiply 2 by something to get to 10? Sure, I can multiply it by 5, right? And that gives me 10. All right, is 3 going to be a factor of 10? Well, I don't think it is, and we can check that by just counting by 3. So if we do 3, 6, 9, 12, we're going to skip over 10, right? So 3 is not a factor of 10. All right, so not 3. Oh, I also forgot to write 2 up here because 2 is a factor. All right, next up we have 4. Is 4 going to be a factor of 10? Well, once again, if we count by 4s, we get 4, 8, 12. We skipped over 10, so 4 is not a factor of 10. And we also showed that 5 is a factor of 10 since 5 times 2 is 10. So we get 5. And we are also still missing 1. We also have 10, and the reason for that is since 1 times 10 is 10, we knew that 1 is a factor of 10, but 1 is also a whole number, so then we know that 10 is also going to be a factor of 10. And this is all of the factors right here. So 10's factors are 1, 2, 5, and 10. All right, let's do 16 now. So what are the factors of 16? Well, what do we need to check up to? So what's half of 16? Half of 16 is 8, right? 8 times 2 is going to give us 16, so we don't need to go anything bigger than 8 because it's guaranteed to be some decimal number, which isn't a whole number, which means those numbers aren't going to be factors. So we just need to check the numbers up to 8. So does 1 give us a factor of 16? Yeah, because we can do 1 times 16 and we get 16, right? All right, how about 2? Does 2 give us a factor of 16? Well, sure, we can do 2 times 8, right? Or if we counted by 2s, right, we do 2, 4, 6, 8, and so on, we would eventually get to 16 after we did 8 2s. That's why 2 times 8 is 16. How about 3? Well, I don't think 3 is going to work because I know that 3 times 5 is 15, And so the next one up would be 18 if we add another 3 to it, and 16 is going to be somewhere in between there, so I'm thinking it's going to be a decimal. And if we count by 3's, we'll see sure enough 16 isn't in the list, so 3 is not a factor of 16. How about 4? Yeah, 4 times 4, right? That's 16. How about 5? 5 isn't going to work because we count by 5s, 5, 10, 15, 20. We skip 16. How about 6? 6, 12, 18. I skip 16, so 6 is not a factor. 7, 14, 21. So 7 isn't going to work because if we multiply 7 by some whole number, we are going to skip over 16. Basically, 7 would have to be multiplied by a decimal to get 16, but that means it's not a factor in the way we're looking at it. And then lastly, we have 8, but we already know 8's a factor from this first one up here. So we can list our factors. We have 1, 2, 4. So that was 1, 2, 4. And then we have 8 and 16, right? Because we have to include these as well. So these are our factors of 16. All right. Next up, we have 9. All right, so what's half of 9? Well, half of 9 is 4.5. But 4.5 has a decimal in it, so we're not going to go strictly to 4.5, but we'll go to the next smallest number of 4. All right, so we just have to check numbers 1 through 4. Does 1 go into 9? Well, sure it does, right? We just multiply it by 9, so 1 is a factor of 9. How about 2? No, 2 is not going to go in because we'll skip right past it when we count. 2, 4, 6, 8, 10, right? 9 is between the 8 and the 10, so 2 is not going to work. How about 3? Yeah, 3 times 3 is 9, right? And 4? 4 isn't going to work because we do 4, 8, 12. We skip right over 9. So 4 does not multiply by some whole number to give us 9, so it's not going to be a factor. So the factors of 9 then are going to be 1, 3, and 9. All right. And lastly here we have 5. So similar to 9, when we divide 5 by 2, we're going to get a decimal number. We're going to get 2.5. So we just have to check numbers 1 and 2. Well, 1 works, and 1 works for any number, right? We know that 1 times 5 gives us 5. So 1 and 5 will be factors. And 2 is not going to give us 5 because we can't multiply 2 by any whole number to give us 5 because we just skip right over it, right? 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, and we've passed 5 at this point. So the only factors of 5 are 1 and 5. All right, so that was number 1, and I wrote here for extra practice, you can choose other numbers and find their factors. So all I did was I just picked random numbers and I looked for their factors. So you can get pretty much infinite examples here if you just choose any number you want, 100, 33, 94, and you just look for its factors, right? So I encourage you to do that to really get comfortable with this process. And let's go on to number 2. Is 12 divisible by 6? How about 5? All right, so let's look at the first part. Is 12 divisible by 6? Well, what does it mean to be divisible by something? It means if we do 12 divided by 6, we're going to get a whole number. Now, do we get a whole number? Well, it's 12 divided by 6. 6 goes into 12 2 times. So yeah, we do get a whole number. So yes, it is divisible by 6. Remember, divisibility was meant to capture like a nice division problem where there's no decimal involved in the answer. All right, and then the second part is basically saying is 12 divisible by 5. So it's asking us for a different number now. All right, well, if we go to do 12 divided by 5, we could actually like solve what 12 divided by 5 is. But we know that if we count by 5s, we have 5, 10, 15, 20. So 5 isn't going to go completely into 12 because 12 isn't part of those counting by 5s list, right? So my guess is we're going to get a decimal answer here. But we can confirm with actual division. So if I do 12 divided by 5, how many times does 5 go into 1? It doesn't, so I have to look how many times 5 goes into 12. It goes in 2 times, because that'll be 10, right? So we subtract off 10. We have the 2 down here, so we get 2 remainder 2. The remainder means we're going to have a decimal for sure. But for the sake of completion, let's actually find what that decimal is. So I add the 0.0, and I bring down the 0. And how many times does 5 go into 20? It goes in 4 times, so our answer is going to be 2.4. So if you don't remember the long division process, I encourage you to review that. It's really useful to know. But in any case, we checked in several different ways that, yeah, this is going to give us a decimal number, not a whole number, so 12 is not divisible by 5. And once again, for extra practice, just pick any two numbers and ask if one is divisible by the other. Is 7 divisible by 4? Is 19 divisible by 30, right? Just pick two numbers and say, is this divisible by the other? And then you can check to see. All right, next up, number 3. Is 14 a multiple of 3? So multiple was another concept that we discussed where basically we're saying that when we're asking is 14 a multiple of 3, we're saying is, can 14 be written as 3 times some number, 3 times some whole number? Or another way of saying it is, can we take multiple 3's and get 14 out of it? So can we have 14 equals 3 times some whole number? Well, let's see. If we take multiple 3's, we just count by 3. So we have 3, 6, 9, 12, 15. So we've skipped 14, which means that we can't take a whole number of multiples of 3 to get to 14, right? This is one multiple of 3, two multiples of 3, three multiples of 3, and so on. But we're never going to have a whole number answer here that'll give us 14 because we've skipped over it in the list, which means that we're going to have a decimal here, which means that 14 is not a multiple of 3. And once again, for extra practice, just like with number 2, pick any two numbers and ask if one is a multiple of the other. And let's go into number 4, true or false. So this first one here, I have A is 5 vertical bar 10. Do you remember what the vertical bar stood for? It stands for 5 divides 10. All right, so that's how we read it. And what was 5 divides 10 the same as? It was the same as the statement 10 is divisible by 5. All right, so is 10 divisible by 5? Well, if we do 10 divided by 5, do we get a whole number? How many times does 5 go into 10? It goes in 2 times, right? So yeah, 10 is divisible by 5. So this one has to be true. All right, part B. A number can be divisible by a number that's greater than it. Okay, so I'm saying if I have some number and I divide it by another number that's bigger than it, will that ever give me a whole number? Well, we can try some examples. So let's say I do 5 divided by 6. So if I do 5 divided by 6, well, we're dividing by something that's bigger than 5. So this is going to be smaller than 1, right? Less than 1. If we divide a number by progressively bigger numbers, it just gets smaller and smaller as you go. For example, 5 divided by 10, that is 0.5. But 5 divided by 20, that is 0.25, right? So it's getting smaller and smaller. But we know that 5 divided by 5, that was 1, right? So if we're dividing by something bigger than 5 here, that means their quotient is going to be less than 1. But if it's less than 1, it's going to be some decimal number, right? Which means that if we divide by something bigger than 5, it's guaranteed to be a decimal, which means that it'll never be divisible by it. So a number can be divisible by a number that's greater than it. That statement has to be false, right? We can try that with other numbers too, but in general, if you divide a number by something that's bigger than it, you're going to be getting a decimal number less than 1. All right, great. Let's go on to part C. 5 is a multiple of 10. Okay, so this one might be tempting because you might think, oh yeah, 5 is a multiple of 10, right? 5 times 2 equals 10, so it should be true. However, this is where the wording gets a little tricky. This says 5 is a multiple of 10, not 10 is a multiple of 5. So 5 is a multiple of 10 is saying that we can take multiple 10s and get a 5 out of it. But that's not true, right? If we count by 10s, 10, 20, 30, we're long past 5. The first 10 that we get is even bigger than 5, right? So we can't actually write 5 as being 10 times any whole number. It has to be a decimal that we'd multiply this by to get to 5. So that means 5 is not a multiple of 10. So always be careful with the wording of these. So this is false. All right, and let's look at part D. There are infinite numbers that are multiples of 4. Okay, so what does it mean to be a multiple of 4? Well, an example would be 8. That's a multiple of 4 since we take multiple 4s, or we take 2 4s and we get to 8. But we can get a ton of multiples of 4 just by counting by 4s, right? We have 4, 8, 12, 16, 20, right? This is a multiple of 4 because we're taking 1 4. This is a multiple of 4 because we're taking 2 4s. This is a multiple of 4 because we're taking 3 4s, and so on and so forth, right? So we can just keep counting by 4s, and there's nothing that will stop us necessarily. So we can get infinite numbers that are multiples of 4. So part D has to be true. But this isn't even just the case for multiples of 4. This would be true for any number, right? We can get infinite numbers that are multiples of 7 by counting by 7s forever. We can get infinite numbers that are multiples of 20 by counting by 20s forever, right? It's nothing special about 4, it's just the nature of what a multiple is. All right, so I have a mystery number that is a multiple of 6. What can I say about this mystery number's factors? All right, so this is a bit of an interesting one, and before I answer it, I'm going to do an example. So let's look at 10, and let's recall what the factors of 10 are. This was in question 1. So those were 1, 2, 5, and 10. Those are all the numbers that we can multiply by a whole number to give us 10, right? 1 times 10 is 10, 2 times 5 is 10, and back and forth. So all of these numbers are factors of 10. Now, let me also look at the factors of 20. Well, the factors of 20 are, and you can confirm this for yourself, but those are 1, 2, 4, 5, and 10, and 20. So these are all the factors of 20. Now, what do you notice? This 1, 2, 5, and 10 are also present here. So basically, all of 20's factors includes all of 10's factors. If I did all the factors of 30, I would have 1, 2, 3, 5, 6, 10, 15, and 30. So these are all the factors of 30. But once again, they include the 1, 2, 5, and 10 from the factors of 10. Basically, any multiple of 10 has 10's factors in it. And why is this? Well, a multiple of 10 is going to be 10 times some whole number, right? But we can write 10 as something like 2 times 5 times that same whole number, or 1 times 10 times that same whole number. And if all of these equal the number that we're starting with, which is like the multiple of 10, then that means 2, 5, 1, and 10, they all have to be factors of this number here, right? So 20, that equals 10 times 2. We know that 10 is 2 times 5. So that means 2 is a factor of 20 and 5 is a factor of 20. And we also know that 10 is 10 times 1. So we know that 10 is a factor of 20 and 1 is a factor of 20, right? So we're just splitting 10 up here into its factors, but that also means that we get a number that is going to be a factor of 20. All right, so the question says is that the number is a multiple of 6. We don't know what it is. It could be 12, it could be 30, it could be 36, right? Those are all multiples of 6. But we know at the very least that it has all of 6's factors. So the mystery number has all of 6's factors since it's a multiple of 6. And those factors are 1, 2, 3, and 6. All right. So I hope number 5 made sense. I think that's a more interesting theoretical question. But in any case, let's go on to number 6. All right, question 6 asks, what are all the common factors between 8 and 20? So for this, we just need to find the factors of 8 and 20 and then find the commonalities. So what's half of 8? That's 4, so we just need to check up to 4. So we know that 1 is a factor of 8, since 1 is always a factor, and that's because 1 times 8 is 8. Is 2 a factor of 8? Yeah, because we know that 2 times 4 is 8. Is 3 going to be a factor of 8? It will not be, because if we count by 3s, 3, 6, 9, we pass 8, so 8 will never be expressed as 3 times a whole number. And 4 is a factor of 8 for the same reason as this. 4 times 2 is 8. So our factors are 1, 2, 4, and 8. All right, let's look at 20. So half of 20 is 10, so we need to check numbers up to 10. All right, so 1 goes into 20, since 1 times 20 is 20. 2 goes into 20, since 2 times 10 is 20. 3 will not, because if we count by 3s, we're going to pass 20, right? 4 will. 4, 8, 12, 16, 20. So 4 times 5 gives us 20. And since we know that 4 times 5 gives us 20, well, we also know that 5 times 4 gives us 20, right? And then we can check 6, 7, 8, 9. If you check those, though, they will not be factors of 20, because if you count by 6s, 7s, 8s, and 9s, it'll all skip over 20. So we can just ignore those. And lastly, we know 10 times 2 is 20. So the factors of 20 are going to be 1, 2, 4, 5, and 10. And I encourage you to check those out for yourself just to make sure everything is right. Oh, All right, so now we can see those. So now we just need to see what are the commonalities. Well, 1, 2, and 4 look like the common factors. So 1 and 2 and 4 are the common factors of 8 and 20. All right, and for extra practice, just pick any two numbers and see what their common factors are. Okay, 7. I have a number that's both a factor of 1,243 and a multiple of 1,243. What is this number? Okay, so this is both a factor of 1,243 and a multiple of it. So I really don't want to have to list all the factors of 1,243 because that's a really big number. So there's probably some trick to this question. All right, so let's start with looking at it's a multiple of 1,243. That means this number can be built by 1,243s. So if we just list the multiples of 1,243, we might get some idea of what's going on. So we have this, and then if we add another 1,243, we're going to get 2,486. And then if we add another one, we're going to get, well, if I add 1,243 to 2,486, what are we going to get? We're going to get 9, 12, 7, 3. So 3,729 will be the next multiple of 1,243. And we can keep going here. So these are all the multiples of it. But these numbers are bigger than 1,243, right? At least like these ones and on are bigger than 1,243. But can a number that's bigger than this be a factor of it? Well, that would be like saying 1,243 can equal 2,486 times some whole number. But this is bigger than 1,243. It doesn't matter what whole number we multiply it by, it's never going to give us a smaller number, right? And so that means all of these will not work as factors of 1,243 because they're just too big, right? But we do know that this would work as a factor of 1,243 since 1,243 equals 1,243 times 1, right? So, and 1 is a whole number, so that means it's a factor of it. But it's also a multiple of 1,243. So this number that has to be 1,243 has to be our answer because it's both a factor of it, where we can multiply it by 1, but it's also a multiple of itself. So as you probably noticed, the amount of questions I had today were a little more than in the number lines video, and that's because I think that there are more interesting problem-solving questions that we should be doing together for these types of questions. But in any case, you ideally have a lot of practice and are feeling more comfortable with these now. If you have any questions, feel free to let me know. But that's going to do it for me today. Have a good one, stay groovy, and I'll see you in the next video.